Hello everyone, and welcome to today's exclusive webinar titled No More Than Your Home Smart Assistant. I'm Biserka, head of the official CertNexus Artificial Intelligence Academy in Semos Education, and today I have the honor to present our guests. Before doing that, I would like to say that I hope that today you will have all the answers of your question regarding the artificial intelligence. I would like to share my presentation now. And start presenting the guests. Regarding the opening of this event, our CEO, Valentina Taseva, will contribute. Our exclusive guest, Jeff Felice, the CertNexus president. Also, before that, I would like to mention there were so many questions regarding the Artificial Intelligence Academy, and I will start with the good news that 25% of you will have off. If you register now, we have 4 seats left. Also, I would like to present you our 5-day artificial intelligence course, and all of you who registered will have 10% off, and all of you who will register in the following 2 weeks. This course starts December 6th, and we have so many questions, but let's start. Please, Valentina, please contribute to the opening. You might have your word.
Hello, everyone. My name is Valentina Taseva. I'm CEO of Semos Education. I would like to wish all of you very warm welcome on our event today. Semos Education is one of the oldest training centers and the biggest one in the region. We exist for more than 26 years. We celebrated our 25th birthday last August. As a part of our team, there are 160 trainers, all of them certified and very experienced. And we have delivered training for 10,000 attendees last year. But we are very proud to say that we are dreamers who do. We dream that we will bring newest IT technologies and newest IT professions in our region, and not only here, also globally. So we started, for example, with software tester many years ago. These days, we are proud to share that we are talking about virtual reality, cloud technologies, big data, or artificial intelligence. Artificial intelligence is a technology or way of living. Very soon it will become a way of living. So this is why we are very proud to have Mr. Jeff Felice, who is president of CertNexus, with us today. He will tell you more about what are the news globally, what are the trends, what is coming, what we can see, what we can feel. I would like all of you to have a great event today. Mr. Felice, please welcome.
Thank you so much, Valentina, and thank you everyone for Semos for taking the opportunity to make this webinar available today, and for everyone that's joining today. I'm going to share my screen, so I'll do that now. And everyone should see a PowerPoint. So I want to start by saying it's here, right? We're going to be talking about artificial intelligence, and as Valentina shared, artificial intelligence is a technology of the future, a technology we consider emerging technology, but emerging technologies merely means that they're technologies that have yet to realize their full potential. So although we don't think about how much we engage with artificial intelligence, most of us engage with it throughout the day. So you think about it, if you're using a smartphone, if you're texting someone and it's auto-completing, if you are using Siri on your Apple phone, if you are doing a search in Google or Bing, all of those technologies use artificial intelligence. And it's not only with our smart devices like our smartphones, it's also in our cars, when we're shopping online, even now when we're shopping in physical retail stores. It's also how, in some cases, our food is being grown, how our cars are being manufactured, how actually items are shipped to us through transportation, etc. So artificial intelligence is ubiquitous today, but it has so much opportunity for growth. And as you'll hear, many will talk about the AI and data economy and how it's transforming not only industry, but our personal lives as well. As Valentina shared, my name is Jeff Felice, and I serve as the president of CertNexus. If you're not familiar with CertNexus, we're a vendor-neutral emerging technology certification company. So we provide certifications in AI, data science, data ethics, IoT, and cybersecurity. And we do that with partnering with our organizations like Semos. So Semos is our preferred provider in the region, and they provide the training that leads to our industry credentials. So what will we discuss today? First, we're going to start with a brief history of artificial intelligence. Then we'll define the types of artificial intelligence, or AI, the various approaches to AI, and then we'll start to just discuss at a high level how AI is actually transforming our industry. Although we will have Q&A at the end, we also do have opportunities for questions throughout. So please do submit your questions through the chat or Q&A, and we'll make sure to address those as we go through the presentation. So I'm going to ask everyone to, if you're familiar with the movie, The Matrix, strap in, lean back, and we're going to give you some hopefully insightful information over the next 35 to 45 minutes here. So let's start with the history of artificial intelligence. So AI, or what considered modern artificial intelligence, at least most of us agree that it actually originated in 1950 with the Turing test out of the UK. Alan Turing was a scientist, and he actually created a test which would test for artificial intelligence in 1950. In the mid-1950s was actually when the term artificial intelligence, or AI, was first coined. It was actually at Dartmouth College here in the US, where I'm based, where the term was first used. And then we started to see the first applications of artificial intelligence. And that actually started with Unimate. That was a robotic arm actually on a manufacturing floor of an automotive company. And then we saw Eliza and Shaky was our first general purpose robot. And what's really interesting with artificial intelligence, unlike many other technologies, which has this continuous progression, in the early 1970s, a few of the experts from academia stated, listen, there was some continued research that happened, but there wasn't the investment that we would expect to see in technologies that are expected to progress. So over a 20-year period, AI, there was little progression within AI. And then for those of us who are old enough, will remember 1997, IBM released Deep Blue. Deep Blue is infamous for beating the Grandmaster champion, chess champion Garry Kasparov at a game of chess. And that really elevated artificial intelligence. People started to realize that machines could actually learn and actually do some tasks better than potentially humans can. And if not better, they could actually do them more rapidly. And in this case, it was beating a person who was obviously a Grandmaster champion at chess in a very complex game. So then we started to see the reinvestment into artificial intelligence. This went on with Kismet, which provided some natural language capabilities. The Grand Challenge, which was the first test for the automotive industry, where there was actually self-driving cars or autonomous vehicles had to circumvent a track. So they did this in the first year. None of the vehicles were able to successfully complete it. In the second year, there was several that were able to actually circumvent the course in an autonomous fashion. But again, much of this was still experimental, right? We didn't see much of this technology in our everyday lives. It was really in the halls of academia or in a few tech companies that were experimenting with the concept of artificial intelligence. And then 2011, IBM supplanted the Deep Blue technology with their current AI technology, Watson. And Watson was infamous in the fact that it had much more capabilities than Deep Blue did at the time. And then DeepMind from Google Google acquired DeepMind, but DeepMind became the prevailing technology in 2016 with the most advanced capabilities, and infamously actually beat the AlphaGo champion. If you're not familiar with Go, it's the most complex board game that you can play, and they were able to beat the champion of that in that game. But what you can see is, again, we started to see some progression of technology, and a lot of it through academia, through research, and really in 2011 to 2016, when we started to see the application of IBM Watson into a commercial space. In DeepMind with Google, we started to see its application in not only commercial, but also consumer applications as well. In 2016 really serves almost as the inflection point for artificial intelligence. Again, we were using it prior to 2016, but in the past 5 years, we've seen an immense amount of investment into artificial intelligence. And these initiatives are rapidly growing, not only in the research community as it had been in academia and other localized research, but also in industry applications. There's not one industry that is not using AI in some shape or form today. Also by governments. There's essentially what we had was the space race in the 1950s and 1960s. We're now seeing that same type of race around AI. Who can essentially create the most capable AI platforms for their nations and for international use. But also we're seeing it in our consumer lives as well. So again, think about it, going back to even the first instance of Siri when it was released over a decade ago, really didn't use AI. It used a number of complex algorithms, but it wasn't AI. Over time, AI was soon used by Apple for Siri and many other applications. But again, over the last handful of years is where we've seen its everyday adoption in not only our personal lives, but also our business lives as well. So we're going to stop here and engage, see if there's any questions that we have at this point in time.
Yes, Mr. Jeff, we have one question, which I like to share. Is artificial intelligence likely to replace most jobs?
Yeah, we're going to talk a little bit about this later on. You know what, it's like any industrial revolution, right? If we were giving this presentation 100 years ago, and I was to ask the question, how many of you are in agriculture, are farmers, are family or farmers? The majority of us would raise our hands, right? If I asked that question 50 years ago, fewer would raise our hands, but I said, how many of us are in manufacturing or our parents are involved in manufacturing? The majority of us would raise our hands. Today, if I ask the question, how many are involved in farming or manufacturing, it's far fewer hands are going to raise up. But if I said, how many of you are involved in providing services? Whatever, you know, a wide array of services. That can be everything from hospitality to retail to IT consultative services, etc. So what we're going to see is the same evolution, is that there will be a number of jobs that move towards obsolescence. So some jobs that exist today won't exist from 5 to 10 years from now. There will be many new jobs. The World Economic Forum actually predicts that there'll be 100 million new jobs created by the AI and data economy over the next handful of years. And then what we'll see is, in most cases, most of our jobs are just going to change, right? So the tasks we do them and how we go about doing them are going to change. So I'm still going to be doing many of the things I'm doing today, but through the use of AI, like just very simply autocomplete, right? I can be writing a text and I can complete that text much more quickly. I can engage with my technology through voice activation, right? Those are the things which are going to change our jobs today, as well as complex calculations that AI will provide for us as well. So what I would say to everyone is definitely work to get to the skills to be able to be proficient in your job today and the jobs of the future, as we always have. But know that as long as you continue to reskill and upskill, you will have a place in the new economy. Any other questions at this time?
Yes, we have one more question, Ms. Jeff. What are jobs that require knowledge of artificial intelligence?
These are great questions. So I would say every job. So there are jobs that we think of, such as a data scientist or an artificial intelligence engineer or machine learning engineer, that obviously require a deep understanding of data and artificial intelligence. But every job today is going to have some understanding. So whether if you're a product manager, a project manager, whether you are a sales operations person, a digital marketing specialist, if you're someone in supply chain management, or if you're involved in legal compliance, whatever it may be, all jobs are going to be affected by artificial intelligence, and you should have at least a foundational understanding of artificial intelligence. Some of it we're going to explore today, but you really need to understand what is machine learning? Why are we using machine learning? What makes good machine learning, and how does it make it valuable to our organization? And again, whether that product or project manager leading a product or project, or a stakeholder or a leader in the business in that C-suite, you really need to have an understanding for these technologies. Great. Any other questions?
Yes, we have a lot more,
Okay.
but we should have one more for this break, and then we'll continue, and then again. Great. So kindly ask you to share information on the application of the artificial intelligence in the law. That's interesting.
Yeah, so it's interesting because there's two sides to this. There's one which is regulation, which has yet caught up to the technology. So the technology right now is somewhat unregulated. So the law is attempting to catch up, and so we can start regulating AI. So we still don't. So we still have highly innovative technologies, but those that are meeting the expectations, whether ethical or legal, from nations or our international community. As far as the impact on law, it's going to be like any industry. It's going to be evolutionary and potentially revolutionary. So all the way from actually writing agreements, you'll be able to train AI to write agreements, to potentially review agreements. You'll also see that AI will be able to provide services within the legal field. So think about even simple questions that come through, the use of chatbots, etc. So when you look at law, again, whether it's regulating AI or AI's impact on law, it will be immense. And again, we'll see this continue to evolve over the next 5 to 10 plus years as well. Great. We really appreciate the questions and look forward to more questions at our next stopping point here. So now we're going to talk about the types of AI. But first, let's define what artificial intelligence is. So really, the most simplest definition is it's for the ability for machines to perform tasks that normally require human intelligence, right? So those things are such as visual perception, right? The computer vision, our speech recognition. So the ability, like Siri or your other assistants, right, to be able to recognize speech and potentially produce speech as well, and other decision-making capabilities as well. So artificial intelligence, right, what we've done is we've given this sentient being term, right, which is intelligence, really only living beings have, not inanimate objects like computers. But we've given this term to machines because machines are able to approximate, again, intelligence that humans may have to perform certain tasks. So if you think about it from a technology standpoint, it's a technology concept. So when we talk about artificial intelligence, as we'll learn later, it's this umbrella concept. And we have various types or progression of artificial intelligence. Today, we have what we call artificial narrow intelligence, or ANI. And ANI is where an algorithm or an AI is able to do something, but that is less than human intelligence, right? So our AI today, they can do very complex things like natural language processing or computer vision or other types of machine and deep learning, but it does one or several things really well, and that's all it does, right? A AI is not able to do the complexity or comprehensive nature of things that we're able to do as humans today. When machines are able to do those things, that would be called general intelligence. And some theorize that we may never achieve general intelligence. Some think we may be able to do the next 5 to 10 years as we continue to advance our algorithms and computational power, especially as we move towards quantum computing. And general intelligence is where machines will have intelligence equivalent to humans. And then there's artificial superintelligence. And superintelligence is where machines would have intelligence greater than humans. Some say we may never achieve this. Some hope we don't, because we may not want machines ruling the world. But again, superintelligence is where machines would have intelligence greater than humans. General intelligence, where machines would have intelligence equivalent to humans. And narrow intelligence, where we are today, where the intelligence is quite expansive, but far less than human capability today. So there's two types of e-learning. So we've talked about artificial intelligence. We've defined this as the ability for machines to approximate or to make decisions similar to human capabilities. We've talked about the fact that we have this progression from narrow intelligence through general to superintelligence, although we're currently in narrow intelligence. But then when we go to apply AI, how do we do that? And we typically do that through machine learning or deep learning. So machine learning is essentially an algorithm where we essentially use, and we'll learn more about this, where we take data and that algorithm is able to predict outcomes. And there's a certain level of guidance that we provide that. Deep learning is a more complex algorithm or set of algorithms that is we'll see structured into a network of layers. And those layers are able to do more complex analysis of information and make more unguided predictions. So typically what we'll see is machine learning is used for, again, really complex problems, but problems that are less complex than deep learning is. How do these concepts relate? Well, artificial intelligence, again, is that umbrella concept, right? So we talk about AI, we talk about the concept of AI. Again, the ability for machines to essentially produce information through completing tasks similar to humans. Then we have machine learning, which is the most common use of AI. Again, it has the most broad applications today. And then we have deep learning, which again may be a subset of, many times considered a subset of machine learning, but again is used for the most complex tasks done today. So how does this work? Well, if you think about our typical known applications, right? So I'm using Microsoft PowerPoint. And although PowerPoint does use some AI now, traditionally, when we think about traditional applications, and I'm going to oversimplify a bit here, are a series of nested if-then statements. So if I click on a cell in Microsoft Excel, it bolds. If I type 1, 2, 3, 1, 2, 3 displays. But that's not how AI or machine learning or deep learning works. How machine learning works is we select an algorithm, and what we do is we take a training set of data and we run that data through the algorithm. That algorithm will make predictions. It then will evaluate those predictions. It learns from those predictions, and then it improves. That's what doesn't happen in traditional programming. Traditional programming is not making predictions, learning from them, and improving that algorithm. That algorithm is static. Where in machine learning, that algorithm is dynamic. It's continuously learning. It's continuing to get better, to make better predictions, more precise predictions from the data that is run through it. So again, when we start to look at the use of machine learning, it is in this way, again, where the algorithm is getting smarter. Deep learning, again, is an algorithm. But what we've done is with deep learning is we process the information over layers. So typically what we'll have is we'll have an input layer. That layer in this case is an image. It goes through one or more layers. In this case, the first layer is looking at that image and it's identifying shapes, a crescent moon, a triangle, a rhombus, an ellipsis. And then what it's doing is looking at those and saying, hey, these are potentially shapes of a face. It could be a mouth, eyes, a nose, or an ear. Then it's assembling that information together and saying, hey, is this a rabbit or is it a human face? And it correctly predicts that it's a human face. So you can see this deep learning algorithm is essentially taking information that we're inputting to it and is starting to process that information and starting to make predictions from that information that has been provided to it through the layers of processing that are completed. So again, as we move into this discussion, we've talked about AI, this general concept, machine learning and deep learning being the various types, and then we're using what we considered artificial narrow intelligence today. Great. Sarika, any questions that we have at this point?
Yes, at this point we have so much more questions. So what's stopping us from making a self-aware machine, the technology or our understanding of it?
Oh, that's a great question. So self-aware machines, it's interesting because there has been some work and progression towards this. In some of it, it's a limitation of technology today. And when we talk about AI, we talk about the algorithms, we talk about the data that we're able to train the algorithms, and then we're also talking about the computational power to be able to power those algorithms. And it's a combination of all three that are limiting a self-aware machine today. Again, we are making strides towards that, and some will say that AI is starting to build some of that capability. There's some recent studies I was reading just as recently as a couple weeks ago, where AI now is starting to understand itself if it's making mistakes or not. But I would expect over the next 5 years, as we see the continued, again, progression towards quantum computing, even if we don't achieve quantum computing, the capabilities of the processing units that we're using, the algorithms, and our ability now to take deep learning and actually start to you have to use less data to train deep learning. We're using now reinforcement learning, which we'll learn a little bit more about, combined with deep learning, which is making for some of that awareness of itself. So all of that over the next handful of years will probably lead to more self-aware AI.
Okay, let's see a couple of more questions. In your opinion, what are the countries that have developed, are developing, and investing the most in the artificial intelligence field?
That's great. So every nation that I'm aware of right now is investing in AI at some level. They realize that both the necessity as well as the potential of AI. So the necessity is from both an economic standpoint, also from a point of not only economic superiority or engagement, but also just from a national prowess or as well. So, you know, at the top right now, it's known that China and the US have invested the most dollars and have made the most advancement in AI, but they're not only the two nations who have done so. You're seeing huge investments throughout European countries, through the Middle East, other parts of Asia, even Africa and South America, and then so in Australia, New Zealand. There's really not a country that's not investing in it today. It's the level with their investing, and that investment is not only in big tech, also in you know, those academic research institutions known for such progressive research, but also it's the democratization of it as well. So it's investing in smaller companies and startups. It's investing in other colleges and universities, investing in its youth as well. So I think what we're going to see is that every nation, or nearly every nation, will be investing in AI. Many of them will be investing through government agencies, through academia, but we're also going to see more and more investment in the private industry as well. And again, not just in big tech companies, but in startups and in other organizations as well.
We have also a more theoretical question. For example, how artificial intelligence, machine learning, and deep learning differ from each other?
Yeah, so machine learning and deep learning differ from one another in that fact, and we'll learn a little bit more about this. But machine learning typically is more, you know more about the information, more and about the expected outcome. So as we'll learn, we'll talk about the ability to essentially look at the measurable characteristics of the data. So we typically know more about that in machine learning, and we're typically know what the what we expect the outcome to be, the ability to label the outcome with machine learning. Deep learning, it's less so. What we do is we take typically larger data sets with deep learning, and we allow the algorithm to process that information and to make and essentially determine what those predictive outcomes will be. Deep learning is also much more complex. Machine learning will be an algorithm that will have a different number of parameters, but typically something that is much more measurable. With deep learning, the largest deep learning or most capable deep learning today is called GPT-3, so it's GPT-3. It was developed by OpenAI and has been since licensed by Microsoft. And GPT-3, not data, but just parameters it uses 175 billion parameters that it runs the data through. So you can see the immensity of that. So again, the big difference between machine learning and deep learning is going to be the complexity of those and the amount of information that you actually use to train the algorithms, and how much guidance is provided to them as well.
Okay, in this discussion break, we will finish with this last question. Then we're going to have another break at the end. So I want to invest in artificial intelligence education. How fast can I get an employment after I'm done with the courses? Can I work remotely?
Yes. Yeah, so like many jobs today, there are many remote options available. And again, that's whether you specialize in becoming a machine learning engineer, or even if you're a product manager, project manager that is developing AI products or managing those projects that utilize AI. In regards to the Certified AI Practitioner course, that course again leads to the Certified AI Practitioner or CAPE credential as well. And that exam was developed with machine learning engineers from industry. And the idea being that when someone actually completes that course and works towards the associated credential, they will have skills and knowledge that will allow them actually to work as a machine learning engineer. So as you complete that course, you'll be able to select an algorithm. You'll be able to then train that algorithm and then move that into a production environment and see how that algorithm works. So you will have the skills necessary to participate as a machine learning engineer within an organization. Great. Thank you. We'll move on to our next section. And again, thank you for all the questions, and we look forward to answering more as we go on. So the approaches to artificial intelligence. So again, we talked about the types of artificial intelligence via machine learning and deep learning. And now we're going to look at some of the most well-known approaches to each one of these. We're going to start with machine learning. We're going to talk about supervised learning, unsupervised learning, and reinforcement learning. So supervised learning, and I started to talk a little bit about this, is a type of machine learning approach in which the values of the variables are known to you, as well as what you're trying to predict. We'll call the output or the label here. So what we'll have is, and we'll use an example of medical records here, is we have data. That data, as we can see, is constructed into a table. And that table has examples. So each ID of a human, an individual, in this case, we've obfuscated it. We've given them an IT number instead of using the name Jeff Felice, right, as you would typically do when using large data sets. But we have an example. Each one of those examples has a measurable property. In this case, in what we call a feature. In this case, the measurable properties are actual things that we can measure within a human, such as weight, height, and blood pressure. And then what we are trying to determine is the label, the outcome of this. In this case, do these patients have heart disease? And you can see some of them have heart disease and others do not. So what we do is we put together all this initial set of data, and we use this data to train an algorithm. So we assemble this together and we run it through the algorithm so we can see what happens on the top. So we take that training data, we take it again with those healthy and those with less heart health. We take it and all of them have those measurable properties, those features of weight, height, and blood pressure, and they're labeled outcome of whether they have good or poor health. And we run it through the algorithm, and the algorithm learns and classifies that information. So it starts to realize that people with certain measurable properties, certain features, typically have certain outcomes, have certain labels. So then what we can do is we take the new data and we run the new data through the algorithm, and that new data, as it goes through, the algorithm learns to make predictions, So if I have a certain weight and a certain height, I may or may not have poor or good heart health, So the algorithm now is starting to predict. And this is what we're starting to learn to do, and we'll learn more about this later on, is in healthcare, we're starting to use AI as our first line diagnostics, We still want a physician or a medical professional involved in that process, but AI is starting to help us determine who may be susceptible to certain illnesses, or people that have, again, certain measurable properties today may be more likely to essentially move towards, become diabetic or have heart health issues further on, So we're starting to use this, and this is how this works. Essentially, we use data to train the algorithm, and then the algorithm can take new data and start to make predictions based on that data. We don't have enough time today to get through unsupervised learning, but unsupervised learning is much like supervised learning, except for we're not labeling the outcome. You can learn more about that as you move on to take classes. But I did want to touch on reinforcement learning today because many of us, whether you're involved in gaming or robotics, reinforcement learning is used in both. So in this case, we'll use an example of a game of chess. So first thing we do is we select an action, which is selecting a chess piece. In this case, we select a pawn. Then what we're going to do is we're going to perform an action. So we're going to move that pawn two spaces forward, and the environment has changed. If that pawn has not weakened the position of, in this case, the black chess pieces, or has not been captured, then the algorithm is going to learn and say, hey, I'm going to essentially, a reward is going to be given. This was a positive move, and the next time I'm going to do that. If the pawn was taken or captured, or if it weakened the position of the black chess pieces, it would know not to make that move next time. And this is how actually IBM Deep Blue was initially trained to actually play chess. It actually played millions and millions of games of chess, and so it was understand what are the best opening moves, what's the best mid game, in the closing or the end game, what are the best moves to do that, as well as to protect yourself as well. And so this is how reinforcement learning works. It's the same with robotics, If a robot sticks out its hand and a human is on the other end of that, the human grasps the hand and then shakes it, it will know the next time when it engages a human to extend its hand. If it extends its hand and it's a dog and the dog just looks at him, it will know that the next time it engages a dog, not to extend its hand to shake as it would a human hand. So again, this is what's called reinforcement learning. Deep learning is, as I alluded to earlier, is made up of neural networks. We call these artificial neural networks, or ANNs. There's two primary types of artificial neural networks: feed-forward neural networks and recurrent neural networks. Again, there's many types of neural networks. These are just two common types of neural networks. And as we'll learn, neural networks, again, we're using sentient being terminology, right? We're using terminology, neural networks, describe something that humans have, right? If you think about our brains, right? Our brains, we have these nodes in our brains, and we're able to, and those nodes are actually connected by synapses, and we send electrical currents over those synapses to those nodes, which allow us to do things like generate speech, to be able to move our hands like I'm doing right now, to be able to read as I'm doing now, to do all those things simultaneously, right? So our brain is connected. It's all these nodes, right, are connected by the synapses, and these electrical currents allow us to do all the things that we do as humans. Well, we've constructed artificial neural networks, or again, ANNs, to again approximate the human brain. So we've created a structure that's similar. And what we do is we essentially have neurons. These neurons are in layers, and these neurons are connected to one another. So what will typically happen, as we saw before, is we'll have an input layer. That input layer is, intaking that information. Then we have our layers that are processing that information, right, starting to make those analytical decisions about the information that has been input to it. And then there's an output layer. And when the output layer is essentially the predictive outcome that we're starting to make, right? We saw in the previous example, right, where we took an image and we were able to process that into initially shapes and then to components of a face, and to assemble that into a face and predict whether it was a rabbit face or a human face, and correctly so, a human face. Well, it's the same thing here. With artificial neural networks, we're able to essentially take that information and be able to process it through that layers and be able to, again, to predict an outcome. So that's how an artificial neural network is actually architected. What we'll see, and again, which is beyond the scope of this webinar, but with artificial neural networks, we're doing things like natural language processing, right? So think about it. If I was to ask Siri, and a lot of times I do this demonstration, but I won't do it today, just for audio quality purposes. But if I was to ask Siri what the weather is today, I'm based outside of Atlanta, Georgia, here in the US. If I was to ask Siri what the weather is, this is natural language processing, and it's doing a number of different types of natural language processing. First, it's speech recognition, right? I'm actually speaking to it. Then it's actually being able to understand that what I'm saying, right? So understanding that I'm asking a question, but I'm asking for specific information, which is the weather in Atlanta, Georgia. And then it's able to generate speech, right? Siri would speak back to me and say, Jeff, today in Atlanta, Georgia, it's 65 degrees Fahrenheit, or 19 degrees Celsius, right? So it would be able to tell me that information. So again, what we see is machine learning we'll see used for many types of AI. Artificial neural networks, which again make up deep learning, we're using it for things like natural language processing, computer vision, and other advanced types of AI. So we have another section for discussion here. Is that okay?
Of course, we have 5 more questions.
Okay, great.
For example, is today's artificial intelligence technology capable to define or identify a problem in the first place in order to solve it?
Yes, it's getting there. So the most advanced deep learning is starting to, again, have some level of awareness, but Still today, we're training those algorithms to help define problems. But it's, so I would say it's not quite there yet, but it's getting, AI is becoming more capable, and some would say that it's starting to be more aware of the simplest problems. But what I would say, just to go on, just to add, is AI it lacks awareness to understand very simple things sometimes. Sometimes even GPT-3, which is, again, the most advanced deep learning, will generate nonsensical information. It doesn't understand awareness in the way we do from an ethical perspective or bias, and we'll talk more about that as well. So it doesn't have the awareness that we have as humans, or even as a baby. It's not even as aware as a baby would be. So
we have more specific one. Mm-hmm. Which area of artificial intelligence would be great for graduate work?
Yeah, so if you're doing graduate work, so whether it's machine learning or deep learning, there's so many applications for AI today. And I would say it's really around where your interest lies. Globally right now, there's more jobs than there are individuals that can actually have skills to pursue those jobs. So although there are obviously some more jobs in certain types of industries than others, it's every industry. So if you're interested in agriculture, it's the pursuit of AI application in agriculture combined potentially with IoT. If you're looking for to be in a big tech company, obviously there's many opportunities there. But we're using it in supply chain, right? We have a global supply chain issue right now. We're using AI to better our supply chain. Transportation. As we saw healthcare, right? There's been many significant studies that have been furthered by AI in healthcare. So if you're studying AI, I would say a few things. One is obviously it's a great opportunity for you, both academically and from a future perspective. Pursue your passions or those things where you think you can make the most difference, because again, AI is being applied across all industry. And then it's also, as we'll learn, is you do that in a way that is going to result in good, right? So responsible technology, which we'll talk more about as well.
Who is making the most progress in developing a general purpose IA model? Are you familiar if they are taking an approach to make the model benevolent in case it becomes self-aware?
Yeah. Unfortunately, the progression of AI again has surpassed our ability to regulate it or ensure that it's being ethical. There's a growing discipline around technology ethics. So you hear of roles like AI ethicists or data ethicists, but it's a big concern, and it's a concern of whether we knowingly will progress technology for profits over being responsibility or concern for the people that use it. Infamously, there was just an issue raised with one of the social media platforms out of the U.S. where they consistently, supposedly anyway, allegedly made decisions for profit over their subscribers again and again, which may have caused harm to their subscribers, but also societal harm as well. So right now, what I will say is that there's awareness of this, but we have yet been able to either regulate these technologies to ensure that they're doing good. And again, because we're unaware of all the capabilities of these technologies today and everything that they're able to do, and the technologies are not self-aware yet, these technologies are doing some things that are not considered to be promoting the wellness of humanity or our global world, including those other than humans. So what I would say is that we need to ensure that we progress regulation in a way that doesn't stem or disincentivize innovation with AI, but it helps to regulate it so it doesn't harm. And then we do need to have this continued progression of understanding within the AI community as well as the ethical community, and the combination of the two to ensure that we're developing technologies as it becomes more self-aware, or even if they're not, that we're developing responsible technology.
We have a question from Stefan. Hello, Mr. Jeff. I think artificial intelligence would be crucial in agriculture to increase food production in the world as one of the biggest problems facing the world. Do you agree?
I do. Just as a personal aside, I was yesterday. I was at a regenerative farm here in the U.S. So a farming practice that goes beyond typical organic practices to a regenerative process, right, which is the full cycle. And so some of it's just our understanding of farming practices that again are regenerative, that continue to add back to the earth and what we grow from the earth, whether it be food or food for animals that we consume. But an AI can help us do that, right? So we're seeing applications of this with along with the IoT or Internet of Things. We're starting to put sensors into the ground, so we better understand essentially many things about the soil. So the minerality of the soil, essentially the pH balance, moisture levels. We're getting better at being able to better utilize water sources in agriculture, so we're not just kind of just spraying our fields all day with to irrigate them. We're starting to do that more targeted. For those who are using chemicals, to use chemicals in a more targeted fashion, and for us maybe to move away from chemical use in our agricultural processes. But it is also going to vertical agriculture and other types as well. And a lot of this is being facilitated by AI. And if you have any interest in food or agriculture, I'd say Google this, because you'll look at so many different applications of this. We're starting to use AI to advance the way we go about growing in our food, and as well as maintaining the soil and those around as well.
2 more questions. Should we expect robots preparing our drinks in bars?
Yeah, I think we're going to see robots. The proliferation of robots is around the corner. And for those who don't know, Amazon just announced that they have their home robot now. I think it's a little creepy that because this robot's recording everything you're doing pretty much, right? The fact is that if you look at it, the robots, we're building ever more capable robots. Robots were typically single-purpose robots, so you'll see a robot being able to do a single weld on or join on the auto manufacturing floor or something like that. But we're starting to create robots now that are actually able to do a multitude of things, have physical awareness, right, of where they're navigating. And being able to do more complex procedures. So if you look at it, Boston Scientific, they have a video. They show these robots dancing, but the complex moves of those robots show the things that robots are going to be able to do. So I do think what we're going to see is more robots doing more things alongside of humans. They're going to replace some human activities, but much like the tractor replaced the ox in agriculture, we're going to see now the replacement of some jobs, but I think we're going to see more that humans will be working alongside robots.
The last one is, will 5G make an impact of artificial intelligence? If yes, then how?
Yeah, 5G I think is going to have a huge impact broadly on technology, right? You think about essentially the capacity for 5G for us to, again, to generate, to share and store more data. The more data that we have available to us, obviously, we will use more and more data to help train AI as well. So I think a lot of people don't really understand the dependency of AI on data. Again, when we talk about training these complex AIs, like GPT-3, they're essentially scraping, billions and billions of data points from the, essentially the general public web, right? So everything that's not considered the dark web. So they're going out and scraping images and text and audio and video, etc. And all that data, the more data that we generate, the more capable of AI that we can develop. Again, understanding we need to ensure that technology is being used for good. So there's this interdependency, and 5G is just going to enable more data. With the enablement of more data is greater AI. Also, what we'll see is, along with 5G, we're going to see other technologies I referred to earlier, like quantum computing. The combination of those technologies is, again, going to vault AI forward as well. Great question. Thank you so much, Berserka. We'll move on to our next section here. And we're going to talk about, again, just at a high level, how AI is transforming industry. And we just selected a few industries here. And these are industries where AI is used extensively, but as we've discussed, AI is used in every industry today. So finance, AI is advancing our finance industry dramatically. It's transforming it. So everything from fraud detection, right? You think about the ability for AI now to actually determine fraudulent activity on a payment card, whether that's a debit or a credit card, or other practices as well. So AI finance is now using that because, again, our criminals unfortunately are becoming more sophisticated. They're using AI in their criminal practices. So we have to use AI to combat AI in some cases, in things like fraud protection. We're also using it in advisory services. So financial advisement firms are starting to use AI to determine, what are the best investments that are going to create the greatest return for their investors, right? So we're starting to look at that. Now, again, our financial markets are highly they're very, very difficult to predict, right? There's no magic ball that you can look into to determine that, but they're looking to make, again, just even small advancements in the services they provide. And then it's around risk assessment and compliance, right? So how do we assess risk? So again, not only do we provide the greatest return, but also ensure that our investors aren't losing on their investments as well. Also, risk investment from a financial perspective of, hey, if I'm a banking institution, how do I ensure when I loan money to individuals that I'm limiting my risk? So how do I identify individuals that are most likely to pay back the loan that's been provided to them? And also around compliance. Finance is a highly regulated industry globally, and so how do we ensure that from a compliance perspective that the practices that are in place comply with the various regulations as well? What I would say about this, with like any industry and we'll learn more about, AI is being applied, but we got to make sure it's being applied fairly. So some of that risk assessment in the lending practices and lending institutions like banks, they're using some AI that has been unfair to certain individuals. For example, some of the initial AI was if you lived in a certain postcode and in that postcode other people defaulted on their loans, you may be less likely to get a loan or at a higher rate, even though your individual credit was good. And so what's happened is we've continued to work to advance the AI so it's less biased against individuals or group of individuals based on location or race or gender or other ways that we measure the viability of someone's ability to pay back a loan. Healthcare, we're making significant advancements with AI in healthcare. We're doing this to a great degree on the diagnostics side. So even if we talk about COVID, and I know we're in the midst of it, and there's a lot of information and a lot of things we don't know, but we're starting to be able to better understand the disease state and those who may be likely to get to the disease, using not only compiling the data, but helping AI to help us to provide potential future diagnostics. We're also using it, for example, we've mapped, obviously, DNA, but we actually just mapped, which was much more complex than this, all the various proteins. That was done by AI. So something that literally we didn't know if humans would be able to do over the next decades, and AI was able to do in a matter of years. And once the AI was developed, now it's able to essentially parse new proteins in far less time. We're starting to use it in prevention. So starting to, again, it's as I was taking those measurable properties of humans and starting to look at all the various factors that we can measure of humans, not only weight and height, but take our blood pressure, our glucose levels, all of the things that we can measure in individuals, and starting to look at, hey, how do we potentially prevent disease, right? And how do we take that information and apply that, whether it's, from our nutritional perspective, activity levels, et cetera. And even in treatment, IBM actually just worked with the Michael J. Fox Foundation around Parkinson's disease. If those who don't know about Parkinson's disease, it has a nonlinear progression. So it doesn't progress in a well understood fashion. Well, with IBM Watson in the Michael J. Fox Foundation, they were able to take vast amounts of data sets and run it through, and now they have a better understanding of the progression of Parkinson's disease, which is huge because now you can better treat it, you can better understand how an individual may progress and how you can treat that individual. It's what they call in the science world N of 1. So you're looking at that single individual and actually able to treat an individual as opposed to be able to treat an individual more to a broader set of rules or guidelines. So again, we're seeing many other applications within healthcare. We're seeing it with implants and that, most people think about brain implants, but I'm talking about in heart implants and other ways that, again, we're starting to use artificial intelligence that can help along with the Internet of Things and other data-driven technologies to advance the field. We're seeing it in retail, right? We all experience this every day. So if you shop online, typically in some way, shape, or form, AI is involved in that, right? It's whether it's the initial ad that was presented to you on Facebook or on LinkedIn or Twitter or Instagram or Snapchat or YouTube, wherever it is, right? Many times those ads, right, are being personalized based on your search history or how you've engaged in a social media platform, right? So that essentially that AI, those algorithms in the background are saying, hey, I enjoy cycling. So if I did a search on Google, as I did over the weekend on cycling socks, I'm now going to start to see cycling sock adverts in my, not only in my web browsing, but also potentially my social media as well, right? So again, that personalization of our engagement with potential items or brands. We're seeing it in how the actual online ordering itself is processed, right? It might even be with the use of chatbots, right? You may be engaging with support that's an automated support up to the point where you need to be able to potentially speak to a person, or that automated support, that chatbot may be able to answer all your questions. We're also seeing it in how your orders are processed and fulfilled. And again, the supply chain management, all of the back end of that, what we don't see. Our ability to track our orders, right? And AI are actually now determining what routes those drivers, whether it's DHL, UPS, FedEx, or the numerous number of transportation companies, right? Delivery companies, how they're actually delivering to our homes. And it's also actually in the retail experience as well. We're starting to see this more and more. Amazon is starting to go to checkoutless experiences where people can just put stuff in their cart in the store and walk out and never check out. And it's just going to be able to, based on using IoT and AI, be able to determine what that person put in their cart and left the store with and charge them to be able to charge their card. So again, the retail experience is, again, being tremendously impacted and innovated by artificial intelligence. We alluded to this earlier, it's also the workplace, right? Every workplace is going to be transforming due to AI, right? We talked about that simple use of, autocomplete on your, when you're texting on your phone. Think about how that's changing our personal lives. And again, our ability to, perform a search on Google or Bing or whatever, DuckDuckGo or whatever your, search engine platform of choice. Think about how you may engage in your home assistant as well. If you have, Google Assistant or Alexa, if you have a Ring doorbell, right? All those things at home, but the workplace is going to be affected as well. And with this, Microsoft has done a study, and they said the digital job capacity, so the jobs that require digital skills, is going to grow from 2020 to 2025 by nearly 100. It'll require 190 million jobs, 150 of them new jobs. And these are going to be in areas that are in data-driven jobs, right? So some of it's going to be around our ability to secure data, to ensure its privacy and our trustworthiness of that data, our ability to analyze data, to use data for predictive outcomes with machine learning and AI. We're going to use more and more data in the cloud, right? That's where we're processing a lot of data, using it for a lot of AI and other data roles. And then obviously software development. Beyond that, better leveraging the data that's available to us. So again, we're going to see significant impact in the workplace as well. And finally is responsible technology. We talked a little bit about this earlier with Zerka as well, is that when we're developing the technology for the first time in ever, but I was going to say the first time within humanity, we've actually are developing a technology that doesn't require us to determine a outcome. And so we need to make sure that the technologies that we're developing, they're developed with integrity, that we understand the potential impact of biases, the potential ethical or unethical use of those technologies, right? So there's a lot of concern around facial recognition. Not that facial recognition itself is inherently bad, but its application, right, is where we are using it. And it may be, for example, there's famous examples in the policing world where it's misidentified an incorrect person that, did not commit a crime as that they had committed a crime. I talked about lending institutions and in providing the ability for someone to access a loan at an appropriate rate. Again, we've had issues with that. We've in other parts of the investment community, et cetera. So we need to make sure, and there's many other examples, but we just need to make sure that we're developing these technologies. We realize that we need to be able to explain how the algorithm came to the result it did. We need the transparency of that information, including the algorithm, which is highly complex, and the trustworthiness of that data, right? Not only from a brand's perspective, but an overall integrity and ethical standpoint as well, that we're developing technology that's going to do good. So in summary, remember going back, we talked about that AI is a technical concept, and we often implement it using machine learning and deep learning. Again, machine learning and deep learning utilize different approaches. So we learned about with machine learning, supervised and unsupervised learning and reinforcement learning. With deep learning, we talked about the fact there's artificial neural networks, and there's various types of artificial neural networks like feed forward and recurrent. AI is used pervasively or throughout the industry today. It's ubiquitous. It's going to become even more so. And again, AI and data economy, it's changing the skills we need to thrive today. We're already seeing that in the workplace, through a lot of these digital transformation projects, and this is only going to accelerate. And we do need to continue to upskill and reskill, right? So we're ready for the jobs of the future as well. So with that, I did want to share briefly CertNexus. We do have a portfolio of both micro-credentials. So at our Think level, these are foundational courses that help someone understand the basics of these technologies. So going a little bit further than we did, like in AI today, in data science and IoT, also around data ethics as well. And then how to build and secure. How do you build these technologies? So how do you develop develop or select an algorithm, train it, and essentially implement that? How do you essentially engineer the data for its use and secure that as well? And then our security for those IT and security professionals. And again, all of these offerings are available through our partner, Semos Education as well. And with that, we'll open it up for Q&A.
Since we are running out of time,
yes,
we are going to answer all these questions left in writing. So we can continue with a short presentation of the Artificial Intelligence Academy. There are a lot of questions about that.
okay.
So we can have just one more question to read and then continue with the information regarding the Academy. How can I tell if I'm human or a robot? So.
Yeah, I mean, fortunately, we don't have any cyborgs as of yet. You know, there's still a huge distinction between robots and humans, and you know, I think it'll be again. That's why we need some of this regulation to be able to ensure that when we employ these technologies, we're doing it to you know, maybe increase the health of individuals and humanity, but not to change it. So.
Thank you a lot, Mr. Jeff. Thank you so much. Now I'm going to share my presentation. There were a lot of questions regarding the Artificial Intelligence Academy. We are starting at the 25th of October. There are only 4 seats left. And the good news is that all of you have 25% off. So please, I would now just paste an application form in the Q&A section. Please fill in this application form wherever you are in the world, and we will contact you and give you any information you need. Okay, I'm pasting here the application form. Okay, if you can see my presentation, I hope you can see it. We have another 5 days artificial intelligence course starting on December the 6th. And all of you who will register 2 weeks from now will get 10% off. Also, the registration application is there. Please fill in. We will answer and contact you. All the questions you have, we're available anytime. I would like to thank you all for being here today. I would like to thank a lot Mr. Jeff. We were honored to have you here. And have a pleasant evening all, and see you next time.